for greatest common factor. Okay? Let's take a look at the picture on page 234 where it has the green and yellow box. You guys see that? In your book, not up here, it's in your book. Okay. That's showing you a stained glass window. Showing you a stained glass window, and it's saying, imagine these are green and the ones that aren't filled in are yellow. Okay? It's saying there are 20 panes in all, single window panes. Does that make sense? Okay. 12 of them are yellow or not shaded. So of the 20 parts, 12 are yellow. You can also look at this in a different way. These are rows of 4 and 5 columns, okay? This is one row. There are how many columns that are yellow? 3. Out of how many total? 5. I can't find a good marker. We'll go back to this one. Three-fifths is just 12 over 20 simplified, right? Instead of looking at it as 20 whole parts, you're looking at it as 5 columns. And instead of looking at it as, of the 20 window panes, 12 of them are yellow, you're looking at the 5 columns, and 3 of those columns are yellow. Okay? I'm going to show you a different way to do it. That's just using a picture instead. Okay. Look at the picture in your book to the right of that, where it says a fraction is in simplest form. Everybody see that? Read it out loud with me. A fraction is in simplest form when its numerator and denominator have no common factor other than 1. Okay? We're going to do the same thing that we did yesterday, finding the greatest common factor, but we're going to do it with fractions. Okay? It's very simple. Let's do actually, you guys just did this one, so it should be easy. 20 over 35. That's our fraction, okay? We're going to take 20 and 35 and find the prime factorization of it first in order to find our greatest common factor, okay? Because you all said that you'd rather do prime factorization over a list of factors, right? Yeah. Okay. So the prime factorization of 20, let's do that real quick.
5.
Yeah, let's do 5 times 4. Is 5 prime or composite? Okay, prime. 4 can be divided into?
2 times 2.
Okay, now those are prime. So my prime factorization for 20 is 2 times 2 times 5. Okay? We still have to do 35 though. 35 is?
7 times 5.
Okay. Is 7 prime or composite?
Prime.
Prime. It can only be multiplied by 1 in itself. What about 5?
Prime.
Okay, that was pretty easy. Do I have any factors in common between 20 and 35? 5. Okay? That is my only factor in common. So my common factor is 5. If I only have one factor, what is the greatest common factor going to be?
5.
5. So I could say it's the greatest common factor. Okay? So let's go back to the fraction 20 over 35. If I divide that by the greatest common factor right here, 5 over 5, I will find the simplest form of that fraction. Braylon, pay attention. Okay, so 20 divided by 5? What's 20 divided by 5? 4. What's 35 divided by 7? So, my fraction was 20 over 35. Simplest form is what?
4 over 7.
Alright, you guys seem to understand that? See how we needed to know the greatest common factor in order to simplify?
So this is looking in the last lesson?
Yes. Wonderful, JT. Okay, this one you guys are going to do on your own. You ready?
Yes. Bring it.
Bring it on, he says.
Bring it on.
We are going to do 6 over 42. So you start off with your 6 and your 42 and find the prime factorization. Okay? You all can do that. 6 breaks into, okay. 42 breaks into, is 7 prime? Yes. The only numbers or only factors that go into 7 is 1 and 7. 6 is 2 and 3. Okay, so 42, my prime factorization is 2 times 3 times 7. What factors do I have in common between 6 and 42? 2 and 3. So my common factors is a 2 and a 3. 2 times 3 is 6, which is my greatest common factor. Okay? So, we'll go back to your fraction, which is 6 over 42. And you are going to divide by your greatest common factor. 6 over 6. 6 divided by 6?
1.
42 divided by 6?
7.
So my simplified fraction is
1 over 7.
Excellent. Okay. Let's do another real quick. Your ticket out. Are you ready? Woo! Here we go. 63 over 70.